fits, more than adequately on an EPC tag. It's, I mean, it's not fatal, so you turn off their SQL server. But remember, if this is on a package and it keeps going from reader to reader to reader to reader, you see how it can get kind of annoying. And of course, system commands. I mean, going back to Microsoft SQL Server, I really do love Microsoft, but they built in this feature into SQL Server that allows database admins to be able to do, system commands from within their database. So they don't even have to leave the database. That's just incredibly handy. But, it's also incredibly handy, of course, for attackers. You guys know this stuff. But this just makes it great for using RFID malware to infect these middleware systems. So, okay, so these are just sort of like the basic building blocks. These are the attacks. And the question is, how can you actually make them, for example, do more interesting things like self-replication? So now I'm going to talk about an RFID worm. So you're going to ask, what is an RFID worm? I'm basically saying that, well, actually, first I'm going to say that a worm is something that replicates using a network connection. It's sort of like what you would think about having a worm on the internet. Usually just, does some port scanning and then basically goes automatically. It's sort of the same way. The RFID worm requires a network connection, and the RFID virus that I'm going to explain next can replicate without the internet connection. But now, assuming your internet connection is available, all it is, and this is really simple, it's just an RFID exploit that downloads and executes malware from a remote location. That's it. And essentially then, the entire logic and the entire intelligence of that attack, of course, is in the malware that you're downloading. So essentially, yeah, I mean, and then that can go and compromise the machine in its typical way. And but the catch is, though, then you ask, how does it self-replicate? Is if you can get the malware, if the malware it downloads modifies the middleware in such a way that it causes the original attack, the original RFID exploit, to get written back to new RFID tags that show up, you've got your self-replication. Once again, I mean, it requires a bit of knowledge about how the system works, but I mean, it's not inconceivable then that you can't implement these things if you sort of know how things work. And then it self-replicates. So at that point, then, the RFID worms can either propagate via the network or via RFID tags. And another thing is, I mean, it's a sort of a little academic exercise if you can just get it to replicate. But you can also put payloads in there. And that can then, for example, do some of the exploit things I was talking about before, like doing system commands. And, you can have payloads in there. And that's what's actually going to do the real damage. So, all right, RFID viruses. I was saying before, these can replicate without requiring a network connection. And the way that I'm going to introduce it is by talking about a typical application scenario. And one of the typical ones out there is supermarkets. So let's say you have a supermarket, and they have a distribution center. And essentially, the way that it works is they're using these RFID tagged containers or these pellets. And essentially what happens is you have the containers that arrive. They're going to be filled with some kind of, like, let's say, fruit, coming back to the apples and peaches and pears. So what happens is that the container comes in. You essentially scan it just to see what the contents are. You unpack the container, because then perhaps you want to process the apples into applesauce or do something like that. You're probably going to wash out the container, clean it, do some things like that. You're going to fill it with something new. This might be, the jars of applesauce. And then you're probably going to write to the tag again that, this container now contains applesauce. It doesn't contain apples anymore. And then, the container, because it's reusable, it just goes on its way to the supermarket at the end of the distribution chain, and everything's happy. So basically, if you think about it, how then would a typical database look in one of these systems? And essentially the way that it would look is you're probably going to have a column in there containing a tag ID. Okay, you have these containers coming in and out, you're indexing them by their ID, that column has got to be in there. Probably what you're going to have is, sort of the known state of the world. So let's say that the last time I scanned this container, it had apples. So So I'm making basically a column called old contents because essentially the last time I saw this container, these were the contents. So as you can see in this here, like for example with tag 123, when the container comes in, it contains oranges. Now let's say you unpack the oranges, and then you go ahead and refill it with apples. But the point is, you still haven't relabeled the tag on the container yet. What you're going to have is something like a new contents column saying, okay, the known state of the world was oranges. I mean, some guy with a keypad is probably going to type in, okay, but it really actually now contains apples. So that's going to be in the new contents column. And essentially what's going to wind up happening is as soon as it's scanned again, the contents of new contents is going to get written into this tag. The tag is going to get scanned again, because remember the system is like continually polling. And then, of course, now apples is going to be the known state of the world. So now the new contents has been cleared, because you've already reset the data and written it to the tag. And old contents is now updated to reflect the new state of the system. So that's essentially the way that I think basically it would probably work. Just for simplicity, I'm calling this the container contents table, just make it easy. So how does the RFID virus work? Now, one of the proof of concept that we did was using a SQL injection attack. So I'm going to explain this. Now, if you take a look at it, probably on an RFID tag, the first thing that you're going to expect is the old contents. Like, let's say that you have raspberries in this crate. Right now here, I put old contents equals raspberries for legibility. Of course, that's just wasting bits, and it's completely not necessary to have there. But I really just put it there for the sake of readability to make this a little bit easier to follow. So you expect up to the semicolon. You expect that you're going to have your old contents equals raspberries. But the part that you don't expect is going to be, of course, when the semicolon starts. And essentially what you're going to do is now you're going to update the container contents table, and you're going to set the value of new contents equal to basically something that you want to be written back to the tags. I mean, you could basically replace the value, you could concatenate the value, just to be fancy. In this case, I said, let's concatenate the old value with our exploit again. Okay, that's cool. So what you wind up happening is you just have the containers, the contents of new contents. Most of the time it's probably going to be empty anyway. And you just concatenate it then with the SQL injection exploit. Okay, so that sounds like it should be good. But then you want to stop and think about what is the SQL injection exploit. So if you try to fill in the SQL injection part, you're going to realize that the SQL injection is actually everything after the semicolon. So what you're going to wind up having is the SQL injection part is equal to update container contents, set new contents equal to new contents concatenated with the SQL injection attack. But of course, this is self-referential. So I mean, at first when we looked at this, we were like, okay, how are we going to deal with this? But we actually came up with a couple different ways. So one way that we figured out you could do self-replication fairly easily was using something like a getCurrentQuery function. I mean, a lot of databases usually have some kind of an administrator command, things like, in MySQL, get the full process list. In Oracle, you're going to have one, in fact, that's demonstrated right here. This select SQL text from vSQL. vSQL is basically just one of those magic data structures where you just pull your administrative info from. And you essentially just make sure you select out the correct currently running query by putting in something distinctive. So here we're saying basically where in the string of the SQL text there is a backtick. I'm just saying a backtick now because that's something you're probably not likely to find in the data. But as we're going to discover later, that instead of using a backtick, that's actually a perfect place to put a payload. So essentially, if you take it and you put it all together, and this is actually an example of a virus that we wrote for Oracle SQL+. This actually works. All you have to do is contents equals raspberries. You do the update of the container contents table. You set the new contents column equal to, of course, the SQL injection attack, which is then basically the select SQL text from vSQL, where you're selecting out the one with the backtick. You're done. And in such a way, you've got your virus, and it does fit on a single RFID tag. And in this particular one, it was basically, I mean, we really had to, I have to admit, part of why we used the backtick was because it was one character, and we were really trying to squeeze with the bits, and this fit exactly on the RFID tags that we were using at the time. So we were also really squeezing with, the select SQL text thing too, trying to get some of this stuff to fit. But here's an example of a slightly more complex example, just so you can see how you can also do other kind of, fancier things using these viruses. So here's another example that we implemented. It's using Oracle and server-side includes. And now, because variety is the spice of life, I'm actually going to, target an insert query instead of a instead of a select query. You can attack several of these things. What you do. Now, you would have apples. Instead of having old contents equals apples, now we just have apples. You close off with a backtick this time, because of course we're using an insert query. And once you close the backtick, then it goes on with the rest. And essentially what you do is then you also add something it doesn't expect. You set the value of new contents equal to, and then you can sort of see this self-replicating part again. This time we used a slightly different format of it, just to use a bit fewer bits. Select substring of SQL text from this position to this position out of that data structure. And essentially, now you're selecting out the specific one. That now instead of using a backtick, you can see that we actually have a server-side include there. And what the server-side include does is when the manager uses the management interface to take a look at to see how his data is doing, it executes the command netcat -LP1234, and it sends it to a shell. And basically, this opens up a backdoor on the system that then the attacker can get into remotely. So one other thing that's notable about it is we're also using, it's hard to see it on the slides, but we're using two dashes to actually comment out the rest of the insert query, because if we don't do that, it basically dies, because the rest of what was actually the valid insert query would cause the whole thing to break. So you need to basically comment it off at the end. And yeah, so and the nice thing about this is this particular one also fits on a 1K tag. So 127 bits, 127 characters in this example, and it still fits on basically still one of the pretty minimal, low-cost RFID tags that are out there. In fact, the particular tag, I think it costs like I think you can get them for 50 cents on DigiKey. So we're not talking about the contactless smart cards here. So another way to do it is doing self-replication with quines. Now the problem with using these get current command queries basically is that sometimes it requires administrative permissions, and occasionally if the database administrator is being smart, he's going to make sure that things aren't running as administrator. So we're looking for basically a more generic way that we can still get this replication to work without requiring these permissions. So another way to do it is with quines. Now you're going to ask, what's a quine? A quine is basically a program that prints its own source code. Now this is stuff like out of the obfuscated C coding contest. If you take a look at a classic example in C, this is what a quine looks like. It's a little bit esoteric, but I'm just going to suffice it to say that the way that it works is it uses some kind of a variable, and it essentially uses the variable to store a copy of itself, and then it uses that to essentially both act as the program code for printing itself, and then also for the data. It's a little bit convoluted. If you want to know a bit more about this, go to Lesher Buck by Douglas Hofstadter. It goes really into a lot of detail.